Right. Now, today I have two things to do. One is to look at very important lesson, that is what is generics when it comes to Java. And also we will be looking at another a complete topic called collections. Right. So these two are very important. Actually, they go hand in hand with something that we did last time, which is interfaces. So as I explained in my previous video, interface is something where you are giving additional capability to a class without inheriting. It's like where you have a parent, then you have a child. So the child will inherit everything from the parent, isn't it? That's the usual connection we have with the child-parent relationship. So the child will inherit everything from the parent. But what if you want to give something new to the child? Let's say to play cricket, a karate, or football, or something like that, let's say, as an example. So if the parent doesn't have karate capability, the child will not get karate. But through interfaces, we can give karate class, we can connect the karate class into the child class also. So inherit uses extends, right? Whereas interfaces uses implements. That's how you connect these two together. Okay, so remember, in simple terms, interface is a way to give new capabilities to the classes that you already have. All right. So with that, we come to the other topic today, which is generic, another very important lesson when it comes to object-oriented principles. Okay, let me switch into the presentation mode. So generic solves another very interesting problem. That is, let's say we are writing individual classes. Okay, say we are writing individual classes where we have actually not classes. Let's say you can do classes, you can also do methods. So if you are to process integers, you will write a method to process integers. If you want to process, let's say, strings, you will write another method to process strings. Or if you want to process real numbers or real floats or whatever, you will write another method to do that. Now, rather than repeating this for each and every method, what if we can write one single method that can take care of everything, right? We did something similar, if you remember the topic of overloading, right? We had a similar concept there, overloading. But generic is beyond that. Now, in overloading, you had to repeatedly write the code. There were code repetition happening in overloading. Yeah. But when it comes to generics, we write only one method, one single method, and it will take up any class rather any data type that you are throwing at it. Okay. So how do you do that? So you write very minimal code to do something amazing. Okay. Now, generics and interfaces are required to understand the collection class, which is another very big topic. So we'll get to that once we're done with the generic. So what is this thing called the generic? So if you look at the definition, it says generics in Java allow you to create classes, interfaces, and methods. So you can create all that operate on any type or any types specified by the user. They provide a way to create reusable and type-safe code. Type-safe as well as reusable. So that when you use a wrong type, the generic will take care of that. So you don't need to worry whether whether to give integers, whether to give strings, whether to give floats, doubles, long, no problem. It will take care of anything. Okay. So how does it work? Well, here's an example. Now, let's say I have a class called box. right? Just a box. And I want to store any data type in that box, right? Now, if I want to store strings, I may have to create a method that takes in, right? That takes in a string. If I want to store integer, then I need a class that will take care of, let's say, integers. Now, in this case, this class, actually, this is a generic class, can take care of any data type that you're giving it, right? How do we do that? We do that by not specifying the data type. So if you look at the code here, you don't see a data type here, isn't it? Instead of a single data type, we are using one letter, right? It's a variable for the data type called T. So if you look at public class box, then we have angle bracket and the letter T there. So that T is now a variable for the data type. Okay, so it can be any data type. So in the next line, I'm saying private T content. So private is the modifier. T is my data type. The variable name is content. Okay. So that's my local variable for the class. And then I have a method called set content. And there also, I am not specifying any data type. I have letter T there. And the variable name is content. So inside the set content, what I'm doing here is, now this is actually a method to get something into it and then store that within the class. So when I call set content, I have to pass something. I have to pass some data type, any data type actually. And whatever I'm passing on will be stored inside the class. So that is what is happening there. Then I also have another method called get content. So set content, get content. Okay. So the get content will take the local data type, which is T, stored in a variable called content, and it will return that. Very simple class. All it does is it receives a data type, actually a data in any data type, and it will store it and then it will give it back. So in order to use that, you can see the example down here. It says box, right? Box, then there is a data type called string. Actually, what we are doing here is we are creating a box and we are passing on the data type now because we are creating a new object called string box. To that, we are passing the data type called string. Okay. So we are basically creating a new box that can store string data type. And when I call string box.set content, I am passing on a string. So hello generics, right? And I can also call it back by string box.get content, and I will get that variable or the data that I stored there. I can use the same type to store integers. You see, I'm using box again, but this time I'm passing the integer data type, and I call it int box, right? So to that int box, I'm passing number 42. So previously I passed a string, hello generics, and in the next one, I'm passing a integer number 42. So I can throw anything. I can give a floating point number. I can give a long number. I can pass anything and it still works, right? And still works. Let me go to another example. Now, this is generic class, by the way, okay? We can also use generic for methods. So in this example, I have a normal class called comparison, and I have a method called find max, right? In the find max, actually, I'm also using another thing that is coming from the collection class, which we will learn in a minute. So what we're doing here is we are comparing two variables, okay, to find out which one is larger. Now, if you notice, this kind of function is required for any data type, isn't it? Whether it is for integers, whether it is for strings, whatever it may be. So you need that for any type. So when you write one simple function that can compare any data type, that will be very, very useful. Yeah. So find max, again, if you notice, we don't have a data type. Okay. We don't have a data type mentioned here. So everywhere you see T. So T, extend, comparable, T. Again, T is the output variable, output value rather, and then we are also passing on first and second. Those are two different variables we are passing to the find max method. So if you simplify that, we are passing two variables to find max, which is called first and second, and we are getting one value out of those two. One will be max. Okay, one will be larger than the other one. So that is what is happening on the next line. Return first dot compare to the second, and if the value we are getting is more than 0, then the first one is the largest, otherwise the second one is the largest. Now, if you look at our operator lesson that we did previously, right? This is a simplified version of using a if-then-else statement called the ternary operator. We have a question mark. Left hand of the question mark is where we are testing something. Right hand of the question mark is where we are giving a true or false a condition. So if it is true, take the first. If it is false, take the second. So it's a very simple method where we can throw in anything and we can compare it. So at the bottom, you can see what is going on here. So the first, I have created a string variable called larger string, and to that, I am calling the find max method from the comparison class. And if you notice, we have not created an object of the comparison class because there is static. When you have static word there, you don't need to create an object in order to use it. So I'm passing the word Java and generics, and then I'm trying to see which one is largest. Okay, so what do you mean by that? Java versus generic. Now there, it is comparing the letters, right? Basically the strings. There is a string comparison going on. On the second one, I'm using an integer and I'm comparing two integers. I'm giving 42 and 17 and trying to find which one is the max, right? So you notice we wrote that method only once, and we are now using it with multiple data types. That's the beauty of generics. And you notice we can use generic classes, right? We can use generic classes and generic methods. These are two different ways of using generics. So in summary, generic in class allow you to create classes that can work with different data type in a type safe manner. Whereas generic method, which is the most famous, allow you to create method that can work with different types of data types, giving lots of flexibility, and also more than that, type safety, so that we don't need to worry about the data type, whether it can handle the data type or whether we will have an error at runtime and things like that. Okay, so let's quickly write a little code to understand how it works. I'm going to switch to my code editor. Let's call it A generics 1. There we go. And here, let's use the same code from the example, the box. Okay. Oh, I could have used the word box. Let me rename that. Okay, so here we go. We have the box class expecting a T here. Okay. And then I also need a testing class in order to test this. So let's create another class. Let's call it tester. And in that, I am going to directly call that box class because I can call the set content there. Okay. So getting it again from the examples. Ooh, sorry, I need public static main. Then I need to put these things there. All right. Ooh. Okay. So here we go with the generics. Oh, public static void and right. So let's run this and see what happens. Oh, I changed the main class. I need to go to main class. Yes, I think it's easy for me to create a new project. So let's call it. um, This can be my testing class. I'm gonna bring this guy over here. And this bring it here. Okay, all good. So basically, what I'm trying to do here is to do a test of my generic class. And let's see how it runs. Okay, build successful. It's working. It's just that I am not displaying anything. So now I can display the value by calling the method here, right? So I can call the get content and display the value. So I go here. So probably after this, I can call here, right? System.out.println. String. Actually, let's copy paste this. Content equals string box dot get content. Okay. So now I can display the value as well. So here I'm going to say int box content. Oops. Inbox content. So now when I run it, I will see the output. Right? String box is hello generics. Int box is 42. So what did I just do? I wrote one class that can take care of any type I am throwing at it. Okay. So that's an example of a class that is supporting us to do the generics. Now, let's write another interesting one where we can use generics, where we can do rather reduce the number of lines required for generic. Third example. Basically reducing number of lines required for my project. So let me do a bit of cleanup. Let's say I want to display an array of information, say integer array maybe, a real array maybe, a character array maybe. I want to display that. Now, how do I do it? Right? So let's start with the integer array maybe. So let me have a little output here. Display array content using for different data types. Yep. So, like I said, let's try to bring in integer array first. Okay, let's try that first. So I am going to write a simple function where I can basically create an array first, right? And then call that to display the array. So first of all, I need to create a bunch of arrays. So let's create a simple integer array first. Okay, so that's an integer array. And I need a method now to display this on the screen. So let me call it display int, right? And if you remember the advanced or the enhance, we call it the enhance for loop. All it does is take the array and go one by one. I need to call this guy display int. All right. I need to call this guy and then pass on the int array to it. So here's my int array variable, and I'm just passing it there. So when I run that, I should be able to see the value 1, 2, 3, 4, 5 along with this word from display int. Let's see whether it works. Yeah, it is working. Okay, let me take it to this side. Okay, much better. All right. So first example is working. Now, what about if I bring in another data type? So let's say I bring in double values. Now, how do I display it then? So, okay, so I'm going to create a double value here. And to do that, I need a display double method, isn't it? If I am to do that, I need another method called display double. Otherwise, the integer function cannot display the double values. So I might end up writing another code here just to take care of the display doubles. So let's run this. Oh, I'm not calling it. So I need to call this guy here, display double, and then pass on that value there. So now, well, I have, oh, sorry, I need to pass double array, not the integer array. Here. So too much code, isn't it? For every data type, I need a corresponding method. Now, if I have another method, another data type, let's say I have a bunch of characters, well, then I need another one to do the same. So say, for example, I have a character array here, then I need another method to display the same. So I am writing too much code now. Let me do that as well here. I already have the method, so that's why I'm copy pasting it from my previous code. So just like what I did here, I need a display character method as well here. So I had to pass that array and I run it. There we go. So I am passing the oh, character array is, oh, okay, it's displaying the character as the numbers. Okay. So basically what is going on here is I have 3 arrays and I'm passing each one separately and it is showing one at a time, right? One at a time. So this is too much work, right? Is there any way where I can write just one method to take care of everything, right? Take care of everything. So let me also put some comment here so that we know what is going on. Now that's where generics is coming into rescue us. So this time I am going to write just one method. This is called a static method. So actually a generic method where it will take any data type. So I'm going to put it as a last one here. Okay. This is called print array. So I don't have a type name. If you notice very carefully, the previous ones, I don't have any return. I'm expecting an integer array. I'm expecting a double array. I'm expecting a character array. Here, I don't have any such type mentioned. I just have the letter T. Okay. So the T is mentioned here with the angle brackets. And just like previously, I have a variable called input array. I'm not going to call it a character or integer or anything, just input array. And then, just like the previous one, I am using the enhance loop and showing one letter at a time. Okay, one letter at a time. Now, for me to call this, now see how simple it will be. I will use the same name, right? 3 times. So first, I'm sending the integer array. Second, I'm going to send the double array. And third, I'm sending the character array. Okay. Now let's see what happens. There we go. Right. So this is from those 3 separate methods. This one is from that single generic method. Right? If you look at the way we are calling, see, it's same in all three: print array, print array, print array. Whereas here, display integer, display double, display character. So there are different methods as well. So this is the beauty of using generic methods, right? So here we can say call the, we can say single generic array, right? Here we have to call different methods depending on the data type. And here we can say with any data type, any, right? So that's the beauty of generics. I hope you understand that now. Okay, so the first example was using a box to put anything inside that. And the second example is where we are using a method. First example uses a class. Second example uses generic method. This is heavily used in our collections that we're going to cover today. All right, so let's switch back to our presentation. Right, so we covered generics now. Let's go to our next lesson, collections. Now, what does this mean? As a word says, collection is about kind of an array where we can store more than one element at a time. Now, when it comes to programming, this is a very, very common requirement, isn't it? We need to store information about students. We need to store information about marks, maybe weather reports. We need to store all kinds of stuff. So not just storing, we also need a mechanism to get it back. Maybe we want to take the one that we stored first, or maybe we want to take the one that we stored last, or we would like to store in a organized or sorted list, right? Or maybe we want to find something very fast. There are very common requirements that we have. We already briefly looked at one such class called array previously, but today we are going to look at other advanced collection methods. Now, there are lots of stuff actually. There are so many different collections available out there, but I have simplified that into very simple things. Okay, just very simple things. So we have list, we have set, we have queue. That's all. And everything else is stemming down from these three. Actually, these three also coming down from one parent class called collection, right? So this whole picture is called the collection class, Java collection class. So Java collection framework. It has lots of very interesting methods that we can call directly, like you want to fill everything in 0 or 100 or whatever number you want. Or you want to delete something, you want to add something, you want to add something to the top, you want to add something to the bottom, you want to sort it. There are all kinds of very interesting methods available for us to use because of this collection class, the way it is designed, right? But everything is simplified into list, set, and queue. So what's the difference between these three? If you start with the first, which is the root or the parent class, it's called collection. By the way, although I use the word class, the proper term here is interface. If you look at the diagram here, it says interface, not class. Why is that? Well, class is where you inherit the class into a child. Whereas interface give you loads of method that you are supposed to basically implement yourself. Right? That's the difference between interface and a class. So here you get lots of code anyways for you to play around and all that. But you need to create the data type you want. And these collections, there are no collection for integer separately or character separately or float separately. They are all one single data code. How? They use generics. Okay, so generic is all about you write once and throw any data type to it. So now you see the collection is using the two of the theories we learned previously, generics and interface. So the collection at the right on the top is the main or the root interface for the rest of it. It represents a group of objects known as elements. And it also has very nice methods like add, remove, contains. Contain is to search something. And also to find the size, there is a size method. Okay. So if you look at the interface for the first one, which is the list, here we have a code for list. It extends the collection, right? Because collection is a parent, list is a child, and list represent an ordered collection or sequence, right? So when you put something to a list, you're looking at a ordered something, right? It also allows you to store duplicate elements. So you can have two Alice, as you can see down here, right? And the common implementations include array list and linked list, right? So we can either use array list or linked list. The parent one is list. So in this case, you can see I have a object name names. I'm using array list of the type list. Now, if you notice here, we use angle brackets. Now, see, with generic, we are saying the names will store strings. And if I call names.add, I am basically adding strings to my names array, or names actually list. Okay. So I can have duplicates, Alice, Bob, Alice again. Duplicates are allowed. So this is list interface. If you look at the set interface, it again, just like the list, extends a collection. But this time, it represents an unordered collection. So the material is not ordered. But one more thing, it does not allow duplicates. So you can't add the same thing again to a set. Okay. So you may notice, although on the left-hand side, we have one type, right-hand side, we have something else. I'll show you the big picture in a minute. Don't worry. Okay, so here we are creating something called the hash set. And just like previously, we start adding element to it. Because it's a set, I cannot have a duplicate. The third one is the map interface. So the map interface is the another one coming down from the collection. This time it uses something called the key value pairs, more like a dictionary. In a dictionary, you search for a word and then you read the explanation, isn't it? So it's like the key value pair. So the key has something, the value has something. And you are free to create any type for the key, any type for the value, which is fantastic. Why is that possible? Thanks to generics again. Now here I'm creating a map, right? Where on the key side, I have string. On the value side, I have an integer. Okay. So I store Alice 25, 34, Bob. So here I don't have the word add, I have the word put. All right. Now here in the angle bracket, I have two data types, string and integer, and age map is my object name, and then I'm creating a hash map. Okay. So the common implementations are hash map and tree map. So this must be unique, by the way. The key must be unique. So you can't have another Alice or another Bob. But this again is another very interesting data type to store the data. So here we have a example, a complete example of a list, right? Let me also show you this one, because this is the implementation side. So if you look at the green color boxes, remember these are the interfaces. You cannot use these interfaces as it is without using some sort of classes. So that's where the implementation classes are required. So when you are using a list, you need to say whether you want an array list or a linked list or a stack or a vector, right? If you're using a queue, you must say, is it a priority queue you want, or is it an array queue you want? On the set, do you want a hash set, link hash set, or sorted set, or tree set? So, stuff like that. That's why you see here, the implementation on the right-hand side is different to the left-hand side. So left-hand side is the top three ones: list, queue, set. As you go down, you need to select a blue color box in order to implement that interface. Okay, so I hope this is clear to you now, right? So there are only three data types, or rather collection type: list, set, and map. But when it comes to implementation, there are so many down there. Okay, so the collection class is another very, very important lesson when it comes to Java. All right, so let's try one, let's say the list, and see whether we can use this for our sample code, because this is required for your midterm as well as for your final project. So you need to have a very good understanding of how these collections work. Oops. A list. Right. So let's just copy paste the code here so that it works fast. There we go. So, oh, I have a red line here. That is because I need to import these from the library. Otherwise, this won't work. So it says add import Java util array list or whatever. So now array list is not imported. I can just put a star here so that it will import everything for me, everything from the utility class, right? So I create a list called names, where I would like to store strings, and the implementation side I'm using array list. And to that I'm adding Alice and a Bob and a Charlie, right? And then in order to print the whole thing, I can just use the name, right? Very simple. Let's see what happens. There I have name, Alice, Bob, Charlie. Now, can I add another a Bob again? Let's see. Yes, I can, right? So it allows to use duplicates. Okay. So now we covered interfaces, we covered generics, and we also covered collections. Now you need to do some experimentation with the different collection classes. The sequence is very similar. Also look at, now for example, when you say name dot, now see what happens. There are so many methods that we can use, so many. Starting from add all, clear, contains, equals, for each, we can iterate through this. There are all kinds of things we can do with the collection, right? To string is another one, to array, so you can convert the collections to arrays and also to strings. You can look at the size of it, right? For example, if I want to know the size of this array, I can say here system dot out dot read line. It has, oh, we'll say number of elements. Okay. So plus names dot size, right? It'll give us a size now. There is a number element 4. So what if I delete this guy now? It should show 3. There it is. It shows a 3. Okay. So that's a very simple example where we can get at these elements beautifully. Okay. Let me stop here for a moment. Okay, for the midterm project, there are 3 questions actually, right? So if your SLTC student number ending with 0, 1, 2, 3, you will do question number 1. And if it is ending with 4, 5, 6, you will do question number 2. And if it is ending with 7, 8, 9, you will do question number 3. Okay. Listen very carefully. You don't need to complete all the code under the midterm project. You will do that for your final project. So this is 2-part project. For the midterm, you get something called the skeleton code going. For the final project, you need to complete the whole thing using the graphical user interface, the logic, and everything else. All right. So this is the first attempt towards that project. And you need to make sure this particular document that you're looking at also part of your submission, right? Your project in the zip file should, or rather must contain this document also. So if you read the notice here, it says minimal code. This is also known as stub functions. This is to prove your logic and navigation is working. You do not need to complete the calculations. You don't need to do that. So please download this document, put your full name, your student index number, and the date of submission here. So the question number 1 is a BMI calculator. So you're supposed to read this formula, and I also included a nice video here. Watch that as well. So your question number 2 is different. It has a blood pressure monitor. There are a little bit of introduction about what is blood pressure monitor. There is basically 2 variables. One is called systolic blood pressure. Other one is called the diastolic blood pressure. So don't try to understand if you don't want to. That's okay. These are 2 different variables. But if you want to, there is a nice video clip here as well. Okay. So we are trying to classify with the result we are getting. And this also explains what it is. The third question is a blood sugar monitor. Again, so it explains what it is, and also we go with the WHO specification, World Health Organization specification. So according to that, here's a classification. Also, another interesting video here. Okay, and then it tells you what to do. So if you go to towards the end of the document, there is a section called paste the code here, right? So you need to paste your code here. If you are using GitHub repo, please make sure you have something called a midterm branch in your GitHub, and then download that zip file and upload it along with your document, plus paste your code here. Then next page says paste the output screen. So if you notice the output you're getting from your NetBeans screen, you can put it here. And the last one is also very, very important. Lessons learned. Okay. So what did you learn by doing this? So that's another important one as well. Okay. So let's go to the first one, because the structure is same for all the questions. Okay. So I'm going to look at the first one, BMI calculator. So This is the formula. So you need to ask the person's weight in kilograms and the height in meters or centimeters. Generally, they tell in centimeters. So 140 centimeters or 120 centimeters, whatever it means. So when you divide the weight by the square of the height in meters, you get a number, right? So if that number is less than 16, then the person we say is under severe undernourishment. If the BMI is less than 16, we say the person is under severe nourishment. And then if it is between 16 and 16.9, we say medium undernourishment. 17 to 18.4, slight undernourishment. Normal nutrition is between 18.5 and 24.9. Okay. And if it is beyond 25 up to 29, we say is overweight. 30 to 39.9 is obesity. That is too much weight, or rather a lot of fat in the body maybe. And then beyond 40 or more than 40 is pathological obesity. That is a serious condition, right? So this is the classification by me. Now, in order to write our Java code, we need two classes. One is our tester class, which is our main class. And the other one is our BMI class. And if you notice the minus and the plus sign, it has a meaning, isn't it? Minus means it is private. Plus means it is public. We learned about encapsulation, which means we cannot allow outside methods to access our private properties. So we need to have getters and setters for that. I showed you how to do that earlier. So if you take the BMI class, BMI has the ID, name, year of birth, height, and weight, right? And then we have a constructor method here for the class with the same name. We also need to have setters and getters for all these variables. And then we also need to have a calculate function and a display function. So this is the BMI class. The tester class has the ID, the name, year of birth, height, and weight. And then, of course, there's a main function. And then here we also have other separate methods for separate things. So we have one called display menu, we have one called index, another one called weave, another one called create, another one called delete, another one called exit. These are different methods within the tester class. Okay. Now, what does that mean? Okay, here's the detail. It says, write an application to store BMI of users. Users, more than one user, which means we may need to use collections. It should be a menu-driven application. You need to show the evidence of using classes, objects, methods, properties, setters, getters, constructors, abstraction, inheritance, polymorphism, and Java collections. So you have to show evidence. Okay. So in your main class, create a display menu method and show the following choices. So you need to create a display menu, which is this one, right? So when you call that display menu method, it will show this menu. Number one, create a record. Number two, show BMI data of all users. Number three, show BMI data for a selected user. Number four, delete all. And the last one is exit application. All right. And if you create this menu, you get 10 marks. So after showing the menu, you need to ask for a choice and then call respective function. So if they select the first one, create a record, what to do? You need to call the create method. Okay. Here you need to call the BMI constructor. So if you notice here, we have a BMI constructor. So you need to call that function. Actually, you are not calling that. You are basically creating a BMI, isn't it? When you are creating a BMI, it will automatically call the constructor. And when they select show BMI data of all users, it will select this one, index. Okay, to show all the records. Remember, it's not one person BMI, multiple people BMI. So we need to have more than one person. So then to show record of one person, we need to pass a ID, right? Remember, there is an ID here, right? ID of the person, of the BMI perhaps. So when someone gives that ID, we need to display the data of that particular person. Then delete will delete all the records. And the last one is exit, will exit to the system. So for each one, you are getting 10 marks. And then the next one, see a section on the lessons learned during this exercise. You see, you are getting 20 marks for that. Menu, you are getting 10 marks. For writing these individual method, you are getting another 10. Writing a essay regarding what you learn, you get 20 marks there. Next is generating the Java doc file. Now, in my week 1 and week 2, I showed you how to automatically generate Java doc file. You do that by putting the proper comments on the top of the method and also on the top of the class, right? So if you have proper comment there, it will automatically generate the documentation for you. So once you do all, by the way, now that you're getting 10 marks, if you generate the documentation. And once you do all that, you have to upload your complete, commented, tested code to GitHub. And make sure you have a branch called midterm. And if you do that, you get 10 marks, right? So the marks are broken down into different things. Now, if you look at the next question, it's pretty much same, right? You see, in your main class, create a display menu, you know, same thing, same sort of marks are coming, right? Now, for blood pressure, now, oh, by the way, what do you do with the calculation? Now, at least in the BMI, there is something to calculate. What do you calculate in the blood pressure? There is nothing to calculate for the blood pressure, but you need to calculate the age of the person. Remember, you are taking the year of birth. Let's say if the user says, my year of birth is 2000, you have to find out the age. You deduct that from the current year. In previous lesson, I showed you how to get the current year using a Java library function, meaning it has to work on any year. So you can't hard code that into 2024. It must get the current year from the system. So even in the next year, it has to work, right? So that you can do in the calculate functions. So same story goes to the next one, the blood sugar here, right? Oh, by the way, coming back to the blood pressure, so there is a age related and also gender related changes also. So if the age is between 1 to 12 months, the minimum blood pressure should be 75/50. Normal is 90/60. Max is 100/70. So there are two numbers. Okay. So the two numbers are diastolic and systolic. So the first is systolic, second is diastolic. So for example, the first one is 75 to 50. So that is somewhere here, isn't it? And the diastolic is 50. That is again 40 to 60. So for a minimum, we are here. For normal, 90 to 60. Right here. That's why it's in the first one. And the maximum is 100 to 75. So by getting the data from the user, you should be able to say whether they come under low pressure condition, normal condition, or hypertension condition. So for that, we have to check this chart, right here. Normal blood pressure number is less than 120/80. So this is the American Heart Association classification. So take this. So I suggest you watch this video first before you attempt the code. Right? So that's the explanation of the project. how do you go about doing this? Well, if you notice in one of the lessons where we talked about loops is where we use do until loop or repeat until loop, right? In that, we made a menu also, right? Let me show that code. So in this example, if you notice, we did different kinds of loops, right? Here's the while loop, for loop, and also we had a do while loop. So this is the loop you will need in order to create a menu. Okay. Let me start this and show you how a menu is designed so that you can do the rest of it yourself. All right. Which may be common for everybody. So I'm going to call it, let's say, midterm. Main class is also midterm. No, wait. Main class should be called tester. Main class is tester. And make sure you have your comment blocks on so that you can generate your Java code. In the tester, according to the document, you need to have certain methods, isn't it? So I already have main. I need to have the rest of the functions. So, for example, you can have it either here or at the bottom of the main. So I'm going to have it here. So you need to have public static, void something to that. So I'm going to first do that. Now this is called stub functions, right? So they don't have any work going on. They're just functions. We will come back to this later for the material inside. So first is to do these methods, right? Okay, so here we go. And then I need to display the menu here. So what am I supposed to display in that menu? Well, the document says that I should display certain things. For example, let me copy paste that again. I need to have these things, right? So let's have a system.out.println. Right. So let's start with the BMI calculator. Calculator. All these are decorations. So create a record is going to be the first one. So number one, that. Then show BMI data for all users is the next one. That's going to be number two. Then show BMI data for a selected user. That's going to be number three. And then delete all can be the next one. Number four, that is. And number five is exit. Right? So that's how you start your coding. Okay. So if I call display menu from my main function, which is here, it will work now. Right? Let's see whether it works. This is called a stub function. Yes, it's coming. Right? Now I need a looping mechanism to basically get the value and then run my activity. So display menu is happening there. I need to have a choice here. So I'll call it choice, okay, int. So what I need to do here is do here while something is true, and then this guy goes inside here. So do while I can say true, right? So here display menu is shown, or we can also say something like Please enter your choice, right? I will remove the ln so that I can get my value here. If you remember the way to get our input, right? Call the scanner function, isn't it? Scanner in equals new scanner system dot in. That's how we got it, right? This we need to input, or rather import here the Java scanner, right? So far so good. And after displaying the menu, we need to get the value into our choice. So we'll say choice equals in, oops, next hint. Okay. And if the number is, something, we keep calling these values. So if the number is 1, we will call index. If the number is 2, not really, number 1 is to create a record, which is this one. So we basically run our menu there, right? So here is where we will have our switch case. Okay, so choice goes into the switch, and then we have our case. Case 1, do something. Okay. So if it is 1, which is create a record, we need to call the create function. So call the create function and break the loop. Oops, wait. So I just need to duplicate it to multiple choices. So number 2 do something, number 3 something, number 4 something, number 5 something. So number 2 is show BMI data for all users. That is the index method. Oh. Number 3 is show BMI data for a selected user, which is the view function. So to that, I have to pass on something else. So I'll pass number 1 for now. So this is, you see, I'm just doing stub function. So delete is the next. Very basic things I'm doing. And then the last is exit. Okay. Very simple program. So if I run this now, what happens? Oh, it says create a record, blah, blah, blah. Please enter your choice. So if I type 1 now, it goes to something and it comes back to the loop because it doesn't do any work. So maybe under the create record, I can have something. I can say system.out.println creating a record here, right? So I don't need to create the record as such, but I can run that. So, oh, I have to close this because I'm I need to stop running the program. I show you to cancel. Yes. Okay. Maybe we need to implement the number 5. Otherwise, I can't stop my program. So here, in order to exit, we do system.exit, right? That will basically exit the program. So number 5 will call the exit function, right? So let's run this again. I'll try number 1. Right, it says creating a record here, right? And then again, back to the menu. So now if I enter number 5, it'll exit. So here also I can maybe have a message saying, thank you for using the BMI calculator, right? Something like that. I'm going to have another slash in here so that it has a new line. Number one, oh, what happened? So here I press number one, I get this, number one, again this, number 5, it says, thank you for using BMI calculator, right? So I'm not going to do the rest of it, then I will be completing your midterm project. But I wanted to show you what is required for the project, okay? This is called stub program. So it doesn't do much work. It only shows that the function is getting called, right? So learn from here. This is how you manage a menu. This is how you display the menu items, right? And we use a switch case function to detect certain choices. And then we call the respective function to do the action, right? I didn't create other classes, like I didn't create the BMI class. So that you need to create. And make sure in this part, you are creating one other object out of that BMI class. All right. Any questions? Okay, then good luck with your midterm project. Go through the instructions and upload that to the provided link. Also, if you have any questions regarding the project, don't send any private messages. I've opened up a forum in the LMS. Please use that to post any question you may have.